Hello everyone, welcome to day 3 of 100 days 100 DSA problem series. So today we are going to see a problem which is find the missing number in an array. So what is this problem? So assume there is an array, okay? So at the moment this array contains how many elements? It's 8 elements. So the problem says if one of the element of this array is removed or missing, then what is the best way you can solve this problem to find that particular element? So what are the prior conditions we need to see before solving this? So first thing is array always starts with 1 in our problem. Okay, so it's numbers from 1 to n. Okay, so they are always consecutive numbers. Second thing is a number that is only single number will be missing. Okay, so in this case, as you can see, right, so there is 6 that is missing. Okay, so this is nothing but a detective work that we should we should do. So where we are planning to find which number is missing in least amount of time, because generally this is the case, right? Whenever there is a crime or something, it's always like time is of very important nature, so it should be solved in a very least amount of time. So similarly here we are planning to do this in very short time. That means our time complexity should be less, or it should be either O of n or whatever that is possible for this question. So how can we go about it? Before going through the solution for this problem, let us just, so this is the detective. So we are the detective that are going to solve this problem. Okay. So this is the formal problem statement. So we are given array of integers containing distinct elements, and they are saying they are consecutive natural numbers. So it doesn't matter, there will be negative integers. Okay, so we are specifically mentioning the number starts from 1 to n, and only one number would be missing at any time. Now what is the input? Input is an array of integers of length n minus 1. Okay, the elements of the array are distinct, so no element is repeated. Okay, so this is very important to remember, because at the end I'm going to give you like 4 or 5 problems where you will trace all these other kind of activities that can happen with this particular array. Like for example, there are certain conditions where multiple elements might be missing, or in this case elements may not be distinct, or these kind of other cases you will be exploring in those solve yourself problems. Okay, next, what is the output? We should return the missing number from the sequence. Whatever number is missing, we should return it. So one example we can take it here. So this is an array of 1, 2, 3, 4, 5. 6 is missing obviously. So our output would be 6. See, whenever you see this problem, you would say the easiest way, the first thought that you will get is obviously to loop through this array, and you always know the first element is 1, right? So you will have something called expected number, which you always know. So at the first place 1 should be there, and the second place 2 should be there, and you will also compare it with actual number, what is actually present there. Okay, so you will start from here, you're expecting 1 and 1 is here. You start, next go to here, you're expecting 2, 2 is here. Similarly you will go till here, you're expecting 5 and actually is also 5. But in this case, next number you are expecting 6. That is, you are just adding 1 to every number that you are passing by. So, but 6 is not here. Next number is 7. So that's when you say 6 is missing. Okay, that is the easiest way to solve the problem. And just, it's also really good way to solve this problem. I am not saying it's the best way, but it is one of the better ways to solve this problem. Okay. So let us see how it's done. So it's called as counting method. Okay. Now, so our goal is to find that 6 is missing, right? So what we are going to do, as mentioned, we will have a for loop or some kind of loop where we will be tracking expected and actual. So expected is nothing but at first place it's 1, and again next place we will say 1 plus 1, and again next place we will say 2 plus 1, and that's how we are going to loop through this entire array. And expected is the number that we are calculating like this, and actually is what actually is present. So what we are expecting at the first place, it's 1. What is actually present? It's 1, right? So obviously we are happy. Next, we are going to loop through the next element. So expected is 2, but actually is also 2. Next, expected is 3, actually is 3. Same case with 4, same case with 5. Now, this is where our expected, which is 5 plus 1, because we are given the condition key, it's a consecutive number. So it's 6. But what is actually present there? 7. So obviously it is wrong. So we are gonna return the expected number. Why? Because expected is 6 but actually 7, so our condition has failed. So actual expected value that is missing is the expected number itself. So that is what we are gonna return. Yeah, so we are successful and we found the, in this place, culprit or someone who escaped from us. Okay. So this is the code. It's like very easy code. You will be having some variable as mentioned as expected, and we are going to loop through array, that is nums array. And if num is equal to expected, we are gonna increase the expected by 1. Or if it is not the expected, we are gonna return the expected, because that is what it's missing. So you can say, right, how many operations it's gonna take at max? It's O of n. Why? Because in the worst case, we should be looping through entire array. Okay, so if there are n elements or n minus 1 element, whatever it is, our time complexity would be O of n. Next, are we like having any new variables, like new arrays that we are using to copy elements from this array or those kind of things? No, we are just creating some constant variables and using them. We are doing something called as in situ looping, like we are looping through this array and solving whatever is required. So the time complexity is space complexity is O of n. Okay. So next we are going to see some other method which is called as binary search for this problem. Okay, so I am giving you the code here itself. So whenever we are doing something in the animation, or whenever we are discussing something, you need to be always, equating whatever I am saying with the code that is present here, that you will get more clarity. Okay. So now our detective has learned after so many years of, doing this detective work. So he has discovered that there are better ways to solve this problem than doing that linear, search kind of thing. So the intuition behind this is, for example, you have an array 4, 6, 7. So here the number 5 is missing. So the intuition is nothing but, if as per the question we know they will always be the consecutive numbers that start with 1. Okay. So that means my array is already sorted. So this is a big point that you need to get from this question. So if array is already sorted, why not see this array, divide this in half, and if I find a way where I can check whether the issue is in the left side or issue is in the right side, then I would only do my analysis on the right side. So again, here I will again divide this. For example, here issue is in the right side through certain condition. Okay, then I will go to right side and again find the midpoint and check whether the issue is on left of it, on the right of it. So at any moment of time, we are dividing our work in half. So we are eliminating half of the values which have zero probability that they have any kind of issue, and doing the work on the remaining half. So every step we are making half. So we are having this. Then if the issue is on the right side, we are having this. So by that way, we are gonna get a time complexity of log 2 or log n base 2. Because every time we are making it half, right? For example, if you are multiplying 2 with 2 every time, what it will become? 2 power n. So if similarly, if you are halving everything, then it will become log n base 2. Okay, so that's how many times. So this is the actual value of 2 multiplied by each other n times, and this is number of times we can divide, whatever element it is there for us by 2. Okay, so simply putting, if we are doing this operation on array of n elements, then it will take log n base 2 operations to reach the base case, which is just having only one element in my execution flow. So what is the base case? Whenever you are doing something, this array is like huge amount of data, right? If you finally reach a case, we are just checking one element, then that is the base case. So it will take log n base 2 operations to reach the base case in case of binary search. Okay, let us just clear this. Now, so let us visualize what is the required way of solving this. See, what we are doing at the start, we are having two variables which are left and right. Left index is the leftmost element of this array and right index is rightmost element of this array. So generally if array is of length 7, we will have right at index 6, left at index 0. Okay. Now, so what now as we are considering entire array, we are having edges here. Left edge is at 0 and right edge is at 6. So whenever we are taking smaller part of this array, left and right will define our boundaries. Okay. Now we have a while loop. The condition is till left is on the left side, right is on the right side. That means till left is less than right. That means they should not cross each other. Okay. So till that condition, we will be looping through this entire array. So what we are doing, I have mentioned, right? If we have a sorted or array already, we need to find where the issue is, like where the actual value is missing. How would you find it? So it's a very easy condition. Before that, we will be finding the midpoint of this array. So what is the midpoint? If you see like visually, these are three elements. These are three elements between. This is the mid. How are you going to calculate mid? It's nothing but left, that is 0, plus right, which is 6, minus left 0 by 2. This double slash is nothing but division and removing the decimal part. Okay. So how much we get? 6 minus 0 is 6 by 2, 3. So we will be getting 3, which is the index of middle element. If you can check here, this is the index of middle element, right? So that's where the midpoint is. So if you can see, exactly this is where the midpoint is. Now, how we are going to know in which direction, on the left part of this mid or in the right part of this mid, the issue is. So it's just, I will see what is the number at mid, that is 4. If it is greater than mid, what is mid? Index 3 plus 1. That means what? That means because at every index, my number that is actually present is nothing but 0 plus 1. 1 plus 1, 2, which is present. 2 plus 1, 3, that is present. So correct element should always be 1 more than the index that is present. So if this condition checks what? If there is a wrong element here. For example, here 3 plus 1 is 4, which is not greater than 4 itself. So that means the element that is present here is correct element. Then we can say all the things which are on the left side of this mid are correct. There was no issue. So then what we will do? So as this condition is failed in our case, what we are going to do? we are gonna just say, because this element like this part has no issues, we don't need to check this. So our left will be moving from here to here, right? Because we have already checked key this till this point there is no issue. So left will be here. So that's what that will happen now. So that's what the code here represent. Left is equal to, that is mid plus 1, that is 3 plus 1 at fourth index. So that's where the left will move. Okay, and again we will be looping and calculating mid. Okay, that's we can see now. So this is the condition, right? So just I'll this rough. Yeah. So we have seen mid is 3, and what is the value at 3? 4. So is array of mid greater than mid plus 1, or element that is present is greater than index plus 1? No. So no issue on the left side. Next, we have already gone through this entire while loop once. Now again we will be coming back. As discussed, initially our left used to be here, but now it is here, right? Because we have changed it. We have found there is no issue in the left side. Now again we need to, now is the left less than right? Yes. So till we are not done with the loop condition. So we will be going inside and finding the mid. Obviously here you can see, right, mid should be somewhere here if you calculate this. So that's where the mid is. Now, is our mid, which is the index, is 5, because 0, 1, 2, 3, 4, 5. What is the element at 5? 7, right? So 5 plus 1 and element at 7. So is 7 greater than 5 plus 1? Yes, obviously. So actually, if you see here, you should be having 6. Then we could have set key. Here the element would be 6. That will not never be greater than 6. Then this condition would have, been happy that the entire array till now has been clear. I mean, there is no issue. But now we are finding 7 is greater than 5 plus 1. So instead of being 6, the element here is 7. So that means it is a wrong value. That means there was some issue on the left side of this number, or if this number itself is an issue, right? So we have found, so we know the issue is somewhere in this direction between the left and mid. So in this case, there are only two elements. Generally, we might, like for example, array is 1000 element array. Then we might be looping multiple times. So now we have found this particular place is where the issue is. Now we are going to forget about this. We already forget about this part. So now we will be looking at this part. So we have, because I have mentioned, so just if you go here, where was right? It was here, right? So now, because this particular condition was passed, we are taking right as mid itself. So if you have seen in the past, mid is here. So right will become wherever the mid is. So that's what it is present here. Now, where is mid? Yes, as per our condition, mid is, let me just for your clarity write the indices here. Left index plus right minus left, which is 5 minus 4, 1 by 2. This is 0, because 0.5 we are going to only take integer value. So we will be having mid at fourth index. So that's what it will happen now, right? So mid is at fourth index. Now, similarly, check the same condition. Where is mid? Is at 4. What is the element at mid? It's 5. Is 5 greater than 4 plus 1? No. That means whatever is element that is present here is exactly where it should be. So here you can see, right, after 4 we got 5. So then what we'll do? So this particular condition will fail. So we'll come here. So now our left will become mid plus 1. So that means left will go here. Okay. So let us see the next part. So left has went there. Now we will be coming to while loop. But our condition has failed. So now left and right are on top of each other, and left is not to the left of right. So now we'll be breaking out of this for loop or while loop in this case and returning left plus 1. What is the left? index 0, 1, 2, 3, 4, 5. 5. So this is where the issue is. So what is the actual number that should be present here? We know index plus 1. So that is what we are going to return, which is 6. So as mentioned, what would be the time complexity? Every time we are having our workspace, if I mention that as a workspace. So we are, first we will have array of n, then we will be working on array of n by 2, and again we will be working on array of n by 2 by 2, that is n by 4. Similarly, we will be reaching till we'll get to this condition, or we are dealing with only one element and this while loop gets disqualified, or the condition in this while loop get value of false. So that is that happens when there is only one element, or we are considering left and right at one element, or they have crossed each other in an inconsistent way. So now how much time it will take? We are again taking by 8. That's how we are dividing by 2 at every moment, the number of elements that we are dealing with. So as I mentioned, how many steps that will take? It will take log n base 2 steps. So you might get this doubt why it's log n base 2, just for you to have an intuitive example. Assume initially there are 4 elements. Okay. Then we are going to deal with how many elements? 4 by 2, that is 2. Again, to get to one element, again we need to divide by 2. 1. So to reach one element, how many times should we divide? It's log 4 base 2, which is log 2 square base 2, that is 2. So we need to divide this entire elements 2 times in half to get to single elements. That's what this represents. So any kind of binary search or places where we're dividing our workspace into half multiple times till we reach one element, generally remember the case would be time complexity of log n base 2. Now, what is the space, space complexity? It is, are we defining any new arrays, or we are doing in situ calculation? As I mentioned, we are using the array that is being passed, right? All other things we are doing is we are declaring some variables with some constant values. So that is O of 1. So it's much better than the counting method that we have just seen. Okay. So do calculation as well as, code walkthrough by yourself and take some more cases and see like how you can solve this problem. Okay. So as we already know, our detective has found the missing number and he is very happy because he has only found that in log n base 2 instead of n time. Okay. And we are also happy because our lecture is mostly done. Now, see, this is part where you need to be solving this by yourself. So you would say why I should solve myself, because I have already got clarity on both the cases, like the counting method as well as binaries, search method. No, these cases I would say are somewhat more tougher than the cases that we have solved in this lecture. Okay, why? Because you got the basic idea or your foundation is good. Now you need to build on top of it. So there won't be any, entirely new method that you need to use for these questions. You need to build on whatever you have learned in this lecture. Okay. So first thing is unique elements. For example, I have mentioned, right? At the moment, the case is that there would be unique elements. There would be no repetitions. Like there would not be a case where 4 will repeat twice. So when there are duplicates, how would you, modify this algorithm to find the duplicate, to take this duplicate case into consideration? That is the first thing. Next, second question is, for example, at the moment I have said there would be only one missing number. What if the case is that there are two missing numbers, or there might be more, more missing numbers? Try to solve and find, the most efficient way to solve these kind of cases. And these are also some other cases where you can, explore. So why I am giving this much importance to this section is that whatever you have learned till now, if you don't apply to these cases, you will never develop your application skills. And in your interview, if there is some very new question, you would be, having some issues with solving that question. So please give some time to this particular try to solve section, and if you have any doubts, please post in the comment section so someone can help, or even I can help in that case. Okay, so that's it from my side today, guys. I wish this lecture or tutorial was helpful to you, and if that is the case, please give a like as well as subscribe to this channel so that we can solve a lot more problems in the future.